Hi, everyone. Today we are going to take a look at the mechanism assigned to me for this week 8 activity. And so we are going to be looking at the hydrolysis of 1-chlorohexane 3,1 via an NHPI intermediate. We're going to take a look at the mechanism analysis regarding electron flow, regiochemistry, and stereochemistry. And so I'll walk you through the curved arrow mechanism for the hydrolysis of 1-chlorohexane 3,1 using N-hydroxythalamide or NHPI as a nucleophile. And we'll take a look at the electrophile and nucleophile involved, track the flow of electrons through each step, and identify any regiochemical or stereochemical considerations. So the first step in this reaction mechanism is the nucleophilic attack. The reagents in this are the 1-chlorohexane 3,1 and NHPI. And the key curved arrows to pay attention to are the lone pair on the NHPI nitrogen attacking carbonyl carbon. And so in the first step of this reaction, we identify the electrophile as the carbonyl carbon of 1-chlorohexane 3,1, which is labeled here on the left. And the nucleophile is the nitrogen of NHPI, which carries a lone pair. And the arrow shows electron flow from the nitrogen to the electrophilic carbonyl carbon, and simultaneously the pi electrons in the double bond between carbon and oxygen shift to the oxygen. And what this does is that it forms a tetrahedral intermediate and sets up a classic addition elimination mechanism, which is typical for an acyl substitution. So the next step in this reaction is the elimination of chloride, which is going to kind of really the mechanism focus is essentially the collapse of the tetrahedral intermediate. And so in this part of the reaction, the intermediate collapses as the oxygen's lone pair reforms the carbonyl bond. This forces the departure of the chloride leaving group, as shown by the curved arrow, pushing the electrons from the carbon chloride bond to the lone chloride itself. And what this does is that it yields a new amide intermediate formed between the alkyl chain and NHPI. What happens next is acidic hydrolysis. And so what's essentially happening is protonation and water attack. So under acidic conditions, the carbonyl oxygen is protonated, which increases the electrophilicity of the carbonyl carbon. And this sets the stage for nucleophilic attack by water, which donates a lone pair to the carbonyl carbon. And this again follows the same electron flow logic that pi electrons shift to oxygen as a tetrahedral intermediate forms. So the next step in the mechanism is the collapse and leaving group departure. And so the mechanism focus is going to be on proton transfers and the collapse of the intermediate. And so what we observe here is proton transfers that help convert the leaving NHPI group into a better leaving species. The nitrogen gets protonated, making it positively charged, while hydroxyl groups shuffle protons to stabilize the system. Then the tetrahedral intermediate collapses again, with electrons from the oxygen restoring the carbonyl and ejecting the protonated NHPI derivative. And the final step is the final hydrolysis and product formation, which is what you see down here. And so the mechanism that's occurring here is the formation of the amine and the phthalic acid. And so what you'll see with the key curved arrows here is the proton transfers and ring opening of NHPI. So more proton transfers occur to neutralize the products. The NHPI undergoes hydrolysis, giving phthalic acid as one product. And then the nitrogen that originally attacked now ends up as a neutral NH2 group, yielding 1-aminohexane 3,1. And this is the final step that completes the full hydrolysis reaction and regenerates stable byproducts. So what I included here is the entire mechanism. So each of the previous slides have just kind of broken down the sections of this. So here's where it starts and here is where it ends. So I want to take a moment now to talk about the regiochemistry and stereochemistry. So this reaction is regiospecific. The nucleophile attacks the electrophilic carbonyl carbon exclusively. No other positions on the molecule are reactive under these conditions. And as for stereochemistry, none of the intermediates generate chiral centers, and the reaction proceeds through planar sp2 carbonyl carbons, which means that there's no preference for attack from one face over the other. And the final product, the 1-aminohexane 3,1, is achiral. So in summary, the carbonyl carbon of 1-chloro-3-hexane-1 acts as the electrophile. NHPI and water acts as nucleophiles in successive steps. The curved arrows in this reaction show lone pairs flowing towards electron-deficient centers. Protonation and deprotonation drive the intermediate stability and as well as the leaving group departure. And regiochemistry is tightly controlled, and stereochemistry isn't really involved here. And this is a multi-step mechanism which illustrates a strategy in the organic synthesis of using acetyl substitution and hydrolysis.